Okay, Mr. Hunt here with volume of prisms and cylinders. You know, I heard a math joke today, so I'll start us off with some fun. Ready? Pause it if you want more time to think. Where do math teachers go on vacation? Times Square. That's a good one. Right? Times and square? I mean, both great math terms. Okay, that was bad. Here we go. Volume of prism. Now, first thing I want to say is notice how we're doing all of these in pairs, right? Surface area, prism, and cylinder, volume, prism, cylinder, pyramid, and cone. They all go together. Cylinder is basically the circular version of the prism, and so they have similar formulas. So volume of a prism, you've probably done one where it was, rectangular prism? You probably did that in the past, so, a box. And what'd you do? Length times width times height, okay? Which is correct for a rectangular prism. But we want something in general that will always work. Well, what's always going to work is if we have a formula, instead of, it's not always length times width. It might be a triangle. So what do we do instead? Well, this is where we do the whole capital B thing again. All right, volume of a prism, capital B times H. Remember, this means, it's very important, base area. Base area. Okay, so for a rectangular prism, sure, that works. Base area, length times width times height. Notice again, you can pick whatever base you want. I could pick this right and left as my capital B. Remember too, this is something that I want to focus on, that little h is always, it's whatever you haven't used yet. So if I was on this rectangular prism, this would be my h. Notice it's not up and down. Okay, so now normally you would pick the top and bottom as the base. Okay, here, let's go back. Normally you'd pick, this is fine too, top and bottom as the base. And so then, sure, this would be your height. All right, so base area times height. When it's a triangular prism, right, it is also base area times height, but notice the capital B. I usually do capital B off to the side. It's a triangle now, right, so this formula changes. 1/2 base times height. And notice do it off to the side. This is a different height, okay? It would be like that height, 1/2 base times height, that height. And so that would be capital B, you get it. Let's say it's like 20, right? Then you multiply by the height. Remember for this one, I'm just making up some numbers, but the height now would be what we haven't used, what extends our figure into 3 dimensions, the non-parallel sides. That would be my height right there, so 10. Okay, now, maybe it would be good if you took some notes off to the side there, or just, copy this down. Feel free to go back, pause the video. The only other thing I want to say about prism and cylinder is that, I'll go to a cylinder here in a sec, it has the same formula. Here's what they want you to know, is basically, in order to get these formulas, in order to get these, the formulas, really what's happening is, look at this, you have a thin triangle, or over here, I could draw in a very thin, I'm doing a cross-section, right? And why these formulas work, it's just the base area, whatever it is, square, rectangle, triangle, in the cylinder, it's a circle. All you're going to do is times it by the height, because really what they want you to know is this, that at each level, at each height, you're doing an area of a figure, and you're just adding up an infinite number of triangles, okay? Or going over here, an infinite number of very, very extremely thin squares going all the way up. How do you count all those? Well, it's just the height, right? That would give us the area of each one, and you add them all up, place them on top of each other, and that's the volume. So that's what they want you to know, is just that it's really an infinite number of these. Okay, for cylinder, it's going to be a circle. Right? You have an infinite number of circles all the way up, and so to cover that, it's just the height. That's what they want you to know. Okay, here's what I want to do. Look down the volume of a cylinder. It's the same formula, capital B times H, but we know the base for a cylinder is a circle, and that circle area, is pi r squared. So pi r squared H. Same formulas. The volume formulas are given to you on the formula sheet. Okay, so here's what I want you to do. I want you to try example 1. And so I want you to try these formulas out. Do your best. I want you to find the volume of the cylinder on the left and volume of the prism on the right using these formulas. And then I just want to compare. It's just a nice little example, beginning example of these. So pause the video, try those real quick. Okay, hopefully you did that. Let's start with the prism. So again, I'm using capital B times H. Let's go ahead and pick the top and bottom as it is right now. That's not the best. All right, we'll pick the top and bottom as our base. So capital B, base area, well, it's 6 times 6. You know what? Let me do this. I always like to do capital B off to the side so we don't get it confused. Base area, what's a square? 6 squared or 6 times 6? 36. Times the height. Well, what extends it into 3 dimensions? It is, it's that value right there, 12. Can you work it out? 432 inches cubed. Oh yeah, we haven't talked about volume, cubic inches, because we're in 3 dimensions. Let's find the volume of that cylinder now. Right, diameter of 6, height of 12. So it's pi r squared h, and the radius is 3, and the height is 12. So 3 squared is 9. Right, 9 times 12, 108, and 108 pi. But what the question asks is, which one's going to, first of all, which one's going to give you more liquid, right? What amount of space it contains? Volume is what it's asking for. So if we would put 108 pi in our calculator, it's going to be about 339.29 inches cubed. So you know how when you go to a restaurant and they give you, a drink, it's normally in a cylinder, right? Well, they're smart. They know that they're actually giving you less soda or less water or whatever when they have a cylinder versus a prism. So in the future, if I went to a restaurant, I would suggest ask for a prism glass, a rectangular prism, right? Because you're just going to get more volume. You're going to get more for the same. Oh, by the way, these have the same dimensions. I should mention that. Same dimensions of height of 12 and a radius diameter or a length of 6. So, all right, and then I always get the question, okay, well, who wants to drink out of a prism? Because it'd be hard to drink out of. Okay, fine, maybe you do want the cylinder. All right, let's try this at the bottom, and then we'll wrap it up here. So, I'm on 2A. Let's see. Oh, I know what I wanted to do with this one. This one just, okay, sometimes they don't give you, right? They don't give you the parts that you need, so you gotta find them. The diameter is 9, right, because it's labeled as in the middle, so that gives us our radius of 4.5. And guys, I always like to write down the formula first. I suggest write down the formula, plug in what you know, and then solve for what you need. Height. Okay, so what's the height? Well, they don't give us the height, but they give us this distance here is 15. All right, and can't get off that. Okay, that's 15. Well, really they should have a right angle in here. I should put that in. So we know it's a right cylinder. Then we can assume we have a right triangle, and we can solve for h. All right, so we can use Pythagorean theorem. Okay, that would work. So if you want to try that, that's great. I would prefer thinking of, isn't it a 3, 4, 5 variety? It is. 3 times 3 is 9. 5 times 3 is 15. 4 times 3 is 12. So it's Pythagorean triple. So it is a p-triple. Okay, so what's the volume? Well, it doesn't say leave in terms of pi. I like to, though. I would specify on a tester quiz. But let's leave it in terms of pi. So in my calculator, I'm doing 4.5 squared times 12, and I get 243. So 243 pi cubic centimeters. Feel free to pause if you need to. I'm going to finish up the last example on B. Okay, so another prism, basically prism, cylinder, volume formula, it's all same idea here. So we need capital B times H. So hopefully you're getting used to these problems where Let's see if I can draw it here. Yeah, there we go. So triangular prism. Hopefully getting used to these problems where you have an equilateral triangle. We've done the area of an equilateral triangle several times. So this is a triangular prism. I'm going to do B first, capital B. Well, it's a triangle. 1/2 base times height, little b. And again, this is all with the triangle. So don't try and say height is this 17. No, that's going to be this h over here. That's going to be the height of the prism. All right, so let's find little b and h. Well, it's an equilateral triangle. And what do? Well, there's 6, 6. This is 6 down here. You draw in the altitude, so these are each 3. And since it's equilateral, that's 60. Nope. 30. 60 and 60 down here. So it's 30, 60, 90. That's the main thing. 30, 60, 90. So the height, let's change colors here. Let's go with some forest green like that. Okay. 3 radical 3. 30, 60, 90. Feel free to do Pythagorean theorem there as well, but 3 radical 3. So let's fill it in. 1/2 the base, not 3. It's this whole distance, that whole length of 6. Right down here, we could have filled that in earlier, times the height of the triangle, 3 radical 3. So I'll do 1/2 times 6 times 3, and that's 9, and then I have radical 3. So let's go back. I don't know much space up there, so I'll write it again down here. What's my volume? Capital B, 9 radical 3, times the height of the prism, 17. 9 times, the simplest radical form, 9 times 17, 153. And then you can leave the radical 3 in there. Squared inches. Wow, cubic inches, excuse me. Okay, that's it for today with volumes of prisms and cylinders. If you need to, feel free to flip back, pause, or rewind, do anything you need to take care of that. Make sure you look online too. There's a lot of notes on Canvas and some other videos and some other helpful resources. All right, Mr. Hunt out.